Application of derivatives. Question number 1. A triangle has two vertices at A bracket A comma 0 and B 0 comma B. Its third vertex C is moving on the line x equal to y. If S is the area of triangle ABC, then ds upon dx is equal to option A minus b upon 2, option B a minus b upon 4, option C minus a plus b upon 2, option D a plus b upon 4. So to find the area of triangle, let be S. So we have to find the area of determinant, which will lead to area of triangle, half 1 1 1, fill the vertex A O 0 B, as x is equal to y, so we can put both of them as x. After solving this determinant, we get half minus bx minus ax plus ab. After differentiating this with respect to s, ds by dx equal to, we get minus a plus b upon 2. So option C is the correct answer. Question number 2. A spherical balloon is filled with 4,500 pi cubic meters of helium gas. If a leak in the balloon causes the gas to escape at the rate 72 pi cubic meter per minute, then rate in meter per minute at which the radius of the balloon decreases 49 times after the leakage begin is option A 9 by 7, option B 7 by 9, option C 2 by 9, option D 9 by 2. So we know the volume of sphere is 4 by 3 pi r cube. Differentiating this with respect to t, we get dv by dt, which is equal to 4 pi r square dr by dt. Let this be equation 1. After 49 minutes, what we get the volume is 49 into 72, which is equal to 972 pi. So the new volume is 972 pi. Let's substitute the value of volume is equal to 4 by 3 pi r cube. We can find the value of r from here. So r will be 9. Now let's find the rate at which the gas is leaked, dy by dt. So the rate at which the gas is leaking is 72 pi cubic meter per minute. So dv by dt is 72 pi, is equal to 4 pi. We get r from here, r square 9 into 9 dr by dt, which we are supposed to find. So after solving this, we get dr by dt equal to 2 by 9. So option C is the correct option. Question number 3. If the function fx is equal to x cube minus 6ax square plus 5x satisfy the condition of Lagrange's mean value theorem for the interval 1, 2 and the tangent to the curve y equal to fx at x equal to 7 by 4 is parallel to the chord that joins the point of intersection of the curve with the coordinate x equal to 1 and x equal to 2, then the value of a is option A 35 by 16, option B 35 by 48, option C 7 by 16, option D 5 by 16. So we have given the function x cube minus 6ax square plus 5x. Differentiating this function, f dash x is equal to 3x square minus 6ax plus 5. So let this be equation 1. Putting the value of a and b in equation in function fb equal to f of 2, which is equal to 8 minus 24a plus 10. On solving, we get 18 minus 24a. F of a is equal to f of 1, which is equal to 1 minus 6a plus 5 equal to 6 minus 6a. From Lagrange's mean theorem, we get f dash x is equal to f of b minus f of a upon b minus a. Substituting the value of f of b and f of a, 18 minus 24a minus 6 plus 6a upon 2 minus 1. Therefore, f dash x is equal to 12 minus 18a. Substituting this value in equation 1, at x equal to 7 by 4, which is given, putting this value in f dash x of equation 1, 3 into 49 by 16 minus 12a into 7 by 4 plus 5 equal to 12 minus 18a. After solving this, we get a equal to 35 by 48. So option B is the correct option. If the displacement, velocity and acceleration of the particle at time t be x, v and f respectively, which one of is true? d square dt upon dx square is common in all the equations, so let's consider that d square dt upon dx square, which is equal to, let's split this term, d dx dt upon dx. Substitute the value of dx upon dt as 1 upon v, which is equal to 1 by v square dv upon dx. After differentiating the first term, we know that v dv upon dx is equal to f, which gives dv upon dx equal to f upon v. Therefore, d double square t upon dx square is equal to minus v square f upon v, which give minus v cube d square t upon dx square equal to f. So option B is the correct option. The distance in seconds described by a particle in t second is given by s equal to a e raised to t plus b upon e raised to t. Then acceleration of the particle at time t is, the given equation is s equal to a e raised to t plus b upon e raised to t. Differentiating this with respect to t, we get ds by dt is equal to a e raised to t minus b upon e raised to t. This is our velocity. Again differentiating it, d double square s by t upon dt square is equal to acceleration, which is equal to a e raised to t plus b upon e raised to t is equal to s, which is our displacement. So option C is the correct option. 6. From mean value theorem, f of b minus f of a is equal to b minus a f dash x1, where a is less than x1, which is less than b. If f of x, our function, is equal to 1 by x, then x1 is a root of ab, b a plus b upon 2, c 2ab upon a plus b, option D b minus a upon b plus a. So a function is f of x is equal to 1 upon x. By differentiating this, we get minus 1 upon x square 1. Putting this in the given formula, minus 1 upon x square is equal to 1 upon b minus 1 upon a divided by b minus a, which we get as 1 upon ab. Therefore, minus 1 upon x square is equal to minus 1 upon ab. So we can write this as x square equal to ab, x1, x1, x1. Therefore, taking square root on both sides, we get x1 equal to root of ab. Option A is the correct option. Question number 7. If y plus x plus y is equal to k is normal to y square equal to 12x, then k is a 3, b 9, c minus 9, d minus 3. So our function is y square equal to 2x. Differentiating this, we get 2y equal to 2y dy by dx equal to 12. So we can write this as dy by dx, which is equal to 6 upon y. Therefore slope to the normal is equal to minus 1 upon dy by dx, which is equal to minus y by 6. And slope, this is slope to normal. Slope of the line x plus y equal to k is minus 1. Therefore minus y upon 6 is equal to minus 1 and y is equal to 6. From y equal to 6, by substituting value in this, we can get x is equal to 3. Putting both this value in this equation, 3 plus 6 is equal to k. Therefore k is equal to 9. Option B is the correct option. The diagonal of a square is changing at the rate 0.5 centimeter per second, then rate of change of area when the area is 400 centimeter square is equal to option A 20 root 2 centimeter square per second, option B 10 root 2, option C 1 upon 10 root 2, option D 10 upon root 2. So let's draw the diagram for our square. X is the diagonal, A are the sides of the square, A, B, C, D. We know dx by dt is equal to 0.5 centimeter per second. This is the rate of change. Therefore area is equal to x square upon 2. Differentiating this with respect to t, dA by dt is equal to 2x upon 2 dx by dt. Therefore dA by dt at A is equal to 400, we get half root of 800. Since we know that A is equal to 400 centimeter square, therefore x equal to root of 800 centimeter. By solving this, we get 10 root 2 centimeter square per second. So option B is the correct option. 9. A cone of maximum volume is inscribed in a given sphere. Then ratio of the height of the cone to diameter of the sphere is option A 2 by 3, option B 3 by 4, option C 1 by 3, and option D 1 by 4. This is a cone inscribed in a sphere. Of diameter, let the diameter of the sphere be AE, which is equal to 2r. Let the radius of the cone be x and the height be y. Therefore AD is equal to y. Since BD square is equal to AD dot DE, or x square is equal to y into 2r minus y. Let this be equation 1. Volume of cone V is equal to 1 by 3 pi x square y, which is equal to 1 by 3 pi y to r minus y into y, which is equal to 1 by 3 pi 2r y square minus y cube. Differentiating this with respect to y, we get dv by dy equal to 1 by 3 pi 4ry minus 3y square. Now dv by dy is equal to 0. We get 1 by 3 pi 4ry minus 3y square is equal to 0. Therefore y 4r minus 3y is equal to 0. Therefore y equal to 4 by 3r. Now double differentiating, we get d square v upon dy square, which is equal to 1 by 3 pi 4r minus 6 into 4 by 3 r, which is negative value. Therefore, volume of cone is maximum at y equal to 4 by 3r. Therefore, height upon diameter is equal to y upon 2r, which is equal to 2 by 3. So option A is correct option. Then the sides of an equilateral triangle are increasing at the rate of 2 cm per second. The rate at which the area increases when the side is 10 cm is option A root 3 square unit per second, option B 10 square unit, option C 10 root 3 square unit, option D 10 by 3 square unit per second. Let x be the length of, of side of equilateral triangle and A be the area. Area of equilateral triangle is root 3 upon 4 x square. Differentiating this with respect to t, we get root 3 upon 4 2x dx by dt. Here x is equal to 10 centimeter and dx by dt, the rate of change of side, is equal to 2 centimeter per second. Therefore, area of equilateral triangle is equal to 10 root 3 square unit per second. So option C is the correct option. Number 11. The angle between the curve y equal to sin x and y equal to cos x is option A tan inverse of 2 root 2, option B tan inverse of 3 root 2, option C tan inverse of 3 root 3, option D tan inverse of 5 root 2. So we have given as sin x is equal to y and cos x is also equal to y. So we can conclude that sin x is equal to cos x, where x is equal to pi by 4. Now differentiating y equal to sin x with respect to x, dy by dx at x equal to pi by 4, we get 1 upon root 2, and y equal to cos x, differentiating this term as well, dy by dx at x equal to pi by 4, we get minus 1 upon root 2. So this is our m1, this is our m2. Tan theta is the angle. Formula is m1 minus m2 upon 1 plus m1 into m2. Substituting the value of m1 and m2 in solving, we get 2 root 2. Therefore, theta equal to tan inverse of 2 root 2. Option A is the correct option. 12. If the normal to the curve y equal to fx at point 3, 4 makes an angle of 3 pi by 4 with the positive x-axis, then f dash of 3 is equal to option A minus 1, option B minus 3 by 4, option C 4 by 3, option D 1. We know that slope to the normal is equal to minus 1 upon dy by dx. Therefore, tan 3 pi by 4 is equal to minus 1 upon dy by dx at point 3 comma 4, which is given. By differentiating, we'll get dy by dx at point 3 comma 4 is equal to 1. Therefore, f dash of 3 is equal to 1. Option D is the correct option. Number 13. The minimum value of the expression f of x is equal to 7 minus 20x plus 11x square is option A 177 by 11, option B minus 177 by 11, option C minus 23 by 11, option D 23 by 11. We have given f of x which is equal to 7 minus 20x plus 11x square. By differentiating once f dash x, we get minus 20 plus 22x. As we have to find the minimum, we can consider f dash x is equal to 0. We get the value of x is equal to 10 by 11. And by double differentiating the term, we get 22, which is a positive value. Hence, at x equal to 10 by 11, f of x will have minimum value at 7 minus 22 or 200, 11 plus 100 into 11 upon 121. Substituting the value of 10 by 11 in equation 1. 7 minus 200 upon 11 plus 100 upon 11, we get answer as minus 23 by 11. So option C is the correct option. Question number 14. The function f of x is equal to 2x cube minus 3x square minus 12x plus 4 has option A no maximum and 1 minimum, option B 1 maximum and 1 minimum, option C 2 maxima, option D 2 minima. F of x is given as 2x cube minus 3x square minus 12x plus 4. Differentiating it once, we get 6x square minus 6x minus 12. Now putting f dash x is equal to 0, we get x square minus x minus 2 equal to 0, and the value of x is equal to 2 and minus 1. Double differentiating f of x, we get 12x minus 6, which is a positive value. So considering f double dash 2, putting the value of 2, we get positive, and f double dash x, putting the value of minus 1, we get a negative value. Therefore given function has one positive and one negative. Therefore option B is the correct option, which have one maximum and one minimum. Number 15. A particle moves in a straight line so that s is equal to root t, then its acceleration is proportional to option A velocity cube, option B velocity, option C velocity square, option D velocity raised to 3 by 2. S is equal to root of t. By differentiating this with respect to t, we get ds by dt is equal to 1 upon 2 root t. ds by dt is v, so we can write this as 1 upon 2 root t. Differentiating again v with respect to t, we get dv by dt, which is equal to 1 upon 2 dot 2 t raised to 3 by 2, which is our acceleration. So acceleration is equal to 1 upon 2 dot 2 t raised to 3 by 2. We can write this term, substitute this term with velocity minus 2 upon 2 root of t raised to cube. Therefore a is equal to minus 2 v cube. Therefore a is directly proportional to v cube. So option A is correct option. Number 16. Volume of water in a trough is x bracket 2x square plus 2x plus 5 centimeter. When the depth of water is x centimeter, water is poured into a trough at the rate of 100 centimeter per second. When the depth of water in it is 5 centimeter, the water level is rising at the rate of option A 4 by 7 centimeter per second, option B 7 by 4, option C 28, and option D 14 centimeter per second. We know volume is equal to x 2x square plus 2x plus 5. We can write this as 2x cube plus 2x square plus 5x. Differentiating this term with respect to t, dv by dt, we get 6x square plus 4x plus 5 dx by dt. Therefore dv by dt is equal to 100 centimeter. We can substitute this value of dv by dt here. 100 is equal to 6 into 25 plus 4 into 5 plus 5 dx by dt. Therefore 100 is equal to 175 dx by dt. Therefore dx by dt is equal to 100 upon 175, which we get as 4 by 7. Option A is correct option. Question number 17. F of x is equal to x cube minus 27x plus 5 is an increasing function when option A, x is less than minus 3. Option B, x mod is greater than 3. Option C, x is less than or equal to minus 3. Option D, x mod is less than 3. So for function to be an increasing, it should be greater than 0. Therefore, f of x, x cube minus 27x plus 5 should be greater than 0. The differentiating term of this f dash x will be 3x square minus 27. So we can write this as 3x square greater than 27. Therefore, x square is greater than 9. X is greater than 3. We have to put a mod here. Option B is the correct option. 18. Root of 49.3 approximately is, to find square root, we have to write 49.3 is equal to root of 49 plus 0.3, where a is equal to 49 and h is equal to 0.3. Now f of x is equal to root of x. Differentiating this once, we get 1 upon 2 root of x. Therefore, f of a plus h is f of a plus h f dash of a. Putting the value 7 plus substituting the value of h as 0.3 and f dash a as 1 by 14. By solving this, we get approximately 7 plus 0.0214. So approximation 7.0214 is not correct answer. So option A is the correct option. Question number 19. X and y are the two sides of two squares such that y is equal to x minus x square. The rate of change of the area of second square with respect to that of the first square is, let A be the area of first square as x square and B is equal to y square, which is x minus x square the whole square. Therefore, we can write dB by dA is equal to dB. Differentiating this with dx and dA, differentiating this with dx equal to 2x minus x square into 1 minus 2x divided by 2x, which is equal to 1 minus x and 1 minus 2x. On solving, we get 2x square minus 3x plus 1. 2x square minus 3x plus 1 is option C. 22x cube minus 6x plus 5 is an increasing function if our function f of x is equal to 2x cube minus 6x plus 5. On differentiating, f dash x is equal to 6x square minus 6. For function to be an increasing, our criteria is f dash x should be greater than 0, a positive value. So 6x square minus 6x should be greater than 0. Dividing throughout by 6, we get x minus 1, x plus 1 greater than 0. So we get x is greater than 1 or x is less than minus 1. So option C is the correct option. 21. The instantaneous rate of change at t equal to 1 for the function f of t is equal to t e raised to minus t plus 9 is option A minus 1, option B 9, option C 0, option D 2. So our function is f of t equal to t e raised to minus t plus 9. Differentiating this once, we get minus t e raised to minus t plus e raised to minus t. Putting t equal to 1 as it is given, f dash 1 is equal to minus 1 upon e plus 1 upon e, which is equal to 0. So option C is the correct option. Question number 22. The volume V and the depth x of water in a vessel are connected by a relation V equal to 5x minus x square upon 6, and the volume of water is increasing at the rate 5x cube by centimeter cube by second when x is equal to 2 centimeter. The rate at which the depth of water is increasing is option A 5 by 18 centimeter per second, option B 1 by 4 centimeter per second, option C 5 by 16, and option D 5 by 13. We have given the volume is equal to 5x minus x square by 6. Differentiating this term with respect to t, dv by dt, we get 5 dx by dt minus x by 3 dx by dt. Putting dx by dt at one side, we get dx by dt is equal to dv by dt divided by 5 minus x by 3. Therefore, dx by dt at x equal to 2 is equal to 5 upon 5 minus 2 by 3, which is equal to 15 upon 13 centimeter per second. So option D is the correct option. 3. Radius of circle is increasing uniformly at the rate 3 centimeter per second. The rate is increasing in area which radius is 10 centimeter will be option A pi centimeter square per second, option B 2 pi centimeter square per second, option C 10 pi, option D 60 pi. dr by dt with a rate of changing of radius is equal to 3 centimeter per second. Our area is surface area is pi r square. Differentiating this term with respect to t, ds by dt is equal to 2 pi r dr by dt. Therefore, ds by dt at r equal to 10 centimeter, which is given, is equal to 2 pi into 10 into 3 is equal to 60 pi centimeter square per second. Option D is the correct option. 24. If y equal to 4x minus 5 is tangent to the curve y square equal to px cube plus q at 2 comma 3, then, well, option A p equal to 2, q equal to minus 7, option B p equal to minus 2, q plus 7, option C p is minus 2 and q plus 7, option D p plus 2 and q plus 7. Given curve is y square equal to px cube plus q. Differentiating this, we get 2y dy by dx equal to 3px square. Therefore, dy by dx is equal to 3p by 2 x square upon y. Therefore, dy by dx at coordinate 2 by 3 is equal to 3p by 2 into 4 by 3, which is equal to 2p. For a given line, slope of tangent is equal to 4. Therefore, 2p is equal to 4, p is equal to 2. Substituting this value in equation 1, 9 is equal to 2 into 8 plus q, which is at this equation. Therefore, q is equal to minus 7. Q minus 7, p plus 2. Option A is correct option. Question number 25. The slope of the tangents to the curve x equal to 3t square plus 1 y equal to t cube minus 1 at x equal to 1 is option A 0, option B half, option C infinity, option D minus 2. The given equations are x equal to 3t square plus 1 and y is equal to t cube minus 1. Differentiating both the equations, we get dx by dt is equal to 60 and dy by dt is equal to 3t square. Therefore, dy by dx is equal to dy by dt upon dx by dt is equal to 3t square upon 60, which is equal to t by 2. For x equal to 1, 3t square plus 1 is equal to 1. So t is equal to 0. Therefore, slope is equal to 0 by 2, which is equal to 0. Option A is the correct option. Question number 26. The equation of the tangent to the curve y equal to 2 sin x plus sin 2x at x equal to pi by 3 is equal to, if x equal to pi by 3, then y is equal to 3 root 3 upon 2 dy by dx at x equal to pi by 3 is equal to 0. Therefore, y minus 3 root 3 upon 2 is equal to 0. X minus pi by 3, that is 2y minus 3 root 3 is equal to 0. We can write this equation as 2y equal to 3 root 3. So option A is the correct option. 27. A ladder of length 17 meters rests with one end against a vertical wall and the other on the level ground. If the lower end slips away at the rate of 1 meter per second, then when it is 8 meter away from the wall, its upper end is coming down at the rate of option A 5 by 8 meter per second, option B minus 8 by 15, option C 5 pi by 8, option D 8 by 5 meter per second. So this is the diagram for a ladder and the wall and the way it is slipping. We have A is equal to 8 and B equal to 15. So we can write A square plus B square equal to 17 square by Pythagoras, as it is 90 degree from the wall. Differentiating this, we get 2A dA by dt plus 2B dB by dt equal to 0. Therefore, 8 1 plus 15 dB by dt is equal to 0. Therefore, dB by dt is equal to minus 8 by 15 meter per second. So option A, B is the correct option. 28. If a particle moves such that the displacement is proportional to the square of the velocity acquired, then acceleration is option A proportional to s square, option B proportional to 1 by s square, option C proportional to s, option C D proportional to 1 by s, option E a constant. If displacement is directly proportional to velocity square, that is s is directly proportional to v square, differentiating this, we can equate this first by putting a constant, differentiating the term ds by dt is equal to 2vk dv by dt. Therefore dv by dt, which is our acceleration, is equal to 1 upon 2k is equal to constant. Option E is the correct option. 29. The displacement x of a particle at time t is given by x equal to at square plus bt plus c, where a, b, c are constant and v is velocity of particle. The value of 4ax minus v square is, x is our given equation, at square plus bt plus c. By differentiating this, we can get velocity as 2at plus b. Therefore, v square is equal to 4a square t square plus 4ab t plus b square, and 4ax is equal to 4a square t square plus 4abt plus 4ac. Multiplying this equation with 4a, we get this equation. Now v square minus 4ax is equal to b square minus 4ac, which is equal to 4ax minus v square is equal to 4ac minus b square. So option B is the correct option. 30. Angle between the tangent to the curve y equal to x square minus 5x plus 6 at point 2 comma 0 and 3 comma 0 is, differentiating with respect to x, we get dy by dx is equal to 2x minus 5. So slope at 2 comma 0 is equal to m1, which is equal to dy by dx at 2 comma 0 is equal to minus 1, and slope at 3 comma 0 is m2, which is equal to dy by dx at 3 comma 0 is equal to 1. Here m1 m2 is equal to minus 1, so tangents are perpendicular, therefore angle between them is 90 degree, pi by 2.